why was Leah able to get it, well, she got it to the ground the first time and then got really close the second time. Why was she able to overpower? Was she lying about how strong she was? There wasn't, okay, so why was she able to?
Does that have to do with the?
And that's because I was in the middle and it wasn't as strong, like, I don't know.
That's a common comment. The tension in the middle would have been very similar to what they were exerting. Yeah, so it's not, the distance did not weaken the tension.
Is it because it was very elastic, the material, the rope?
No, it's not particularly elastic. I mean, I could pull it like that. Something all I'm doing is straightening it out. Yeah, it's not a very elastic material. We're just gonna settle for Leah's route.
Maybe because she was going down in a different direction, so they was pulling and she was going down.
Ah,
I don't know.
say it with confidence.
Okay, maybe, yeah, maybe because they was
Not
pulling,
maybe.
well, they was pulling in different directions and she was pushing force downwards.
Yes. Most of the effort that Julissa and Juan were exerting were against each other. Very little of their effort was actually against Leah, because they were pulling this way to start with. Eventually they were pulling at an angle, so thus there was a little bit more resistance as the angle went down. Then part of their force was up and away. Still, most of their effort was against each other, with a little bit acting up. The moral of this there are certain times in which direction makes a huge difference. Now, also how hard they were pulling made a difference too. So there was a quantity, there was the amount of force they were applying, and there's the direction they were applying that force. If the quantity and the direction both matter, we're dealing with vectors. Now, for those of you who have your computers open, if you take notes on your computer, I know that's a thing now for some people, that's fine, but if you're not taking notes on your computer should be shut. The direction and amount matter. And we need to deal vectors. If only amount matters. Anyone happen to know what the word is? It's the math you've been doing since kindergarten. Although probably, I'm guessing if your kindergarten teacher was anything, kindergarten teacher was like mine, he never mentioned it. Scalars. The math is a little bit different between scalars and vectors. Scalar math is the math that you've been doing. There's 10 people in the room, 5 more people enter. Direction doesn't matter. It's just a matter of there's a number of people. That's scalar math. Now, how do you know if you're dealing with a vector or you're dealing with a scalar? Well, there's one. Sometimes you can just think through it, like then where direction mattered, you can go, okay, direction matters, so we would, if we did an analysis of that, we'd be dealing with a vector. So first off, there's certain symbols that indicate a vector, and then there's certain words that indicate a vector. So first off, in terms of symbol, if I wrote F with that over it, that's indicating we're talking about a vector. Direction matters. I can also write it like that. It's harder to do when I'm handwriting. That's much easier to do when I'm handwriting, but on the computer, when I indicate something's a vector, that's the symbol that's gonna show up on the stuff that I type up. Some textbooks will indicate vectors by doing boldface print. Obviously not particularly convenient when handwriting. And then the other way that I sometimes will do it, there's actually one situation where I do what I call the double print. These are all indications that whatever f is, it is a vector quantity. I tend to use the first one in class the most. So that's it for the symbols. Keywords. Force is a vector quantity. So we're talking about forces, direction matters. Position is a vector quantity. Displacement. Velocity. Acceleration. These are the primary vector quantities we will be dealing with in at least the first part of the course. Oh, I guess chapter 6, momentum, is also a vector. There are also rotational or angular analogs of this. Angular velocity, angular acceleration, angular momentum are also vectors. All right, scalars, some keywords that tell you that you're dealing with a scalar. Time. Time is a scalar. Mass is a scalar. Distance. Speed. Energy. And then one that you're not particularly going to care for, that it's a scalar. Acceleration. Now, if you'll notice, acceleration is in both columns. There is a scalar acceleration and there's a vector acceleration. It would have been really nice if they'd come up with a different word, but they didn't. So, you're taking a test or quiz, or doing a master set, and you're looking at it and it asks for acceleration, which one are you supposed to find? Usually, it's based on context. But if you're just starting out, which most people in 110 are, you might not be able to look at the problem and go, oh yeah, they're looking for the vector one. On a quiz or test, I will put acceleration, comma, A. If I want the scalar, I'd write it like that. If I want the vector, I'll write it like that. If you're looking at some of the old tests, I might not have done that as much, but it is just on at least the current ones, I'm either putting the A without the vector symbol or the A with the vector symbol. B, and if I forget or you're not sure, just ask. I can respond with, oh yeah, the vector one or the scalar one, or you should be able to pull, you should be able to guess from the wording what it is. For example, if I say that an object has an acceleration, that would be from context. We'll get into the subtleties later. All right. Questions up to here? All right, let's talk about some vector math. Oh, actually, there was one other vector that I probably should do now. If you see the hat over it, if you use LibreOffice or OpenOffice and you're doing the equation editor, hat is the keyword there. The hat indicates a special type of vector. When you see this hat, indicates a unit vector. It is a vector. It does have a magnitude and direction. So first off, the magnitude of a unit vector, what would you guess is the magnitude of it? How big it is of a unit vector? Someone be bold. Say it with confidence. What does unit mean? We are all gonna make mistakes in here. It's okay.
You said what's a unit mean?
Yeah.
The form of measurement?
The unit of measure, talk about just unit. The units place? There's a tens place, a hundreds place. Thank you. Say it with confidence, like you mean it.
One.
Yes, unit, 1. A unit vector has a size of 1. There are no units of measure. It is just 1. Now, to write the magnitude as a unit of 1, I could write all those words out, but oh god, so many letters to write. Let's see if there's a shorthand notation for it. I'm going to write that the magnitude of the unit vector is 1 by using absolute value marks. This is shorthand for the magnitude, that's the absolute value marks, of the unit vector is equal to 1. And there are no units of measure after it. Now, it is a vector, so it has to have a direction. Up until we get to chapter 8, the direction of the unit vector is what we say it is. Now, there's certain conventions involved, but we'll get into that about how you actually use it to save time writing out words. Okay, I've got a box here, and I am pushing on it with a 5 Newton force. Newton is the unit of force, the SI unit of force, international standard, Standard International. Someone with better French accent? Then we are going to settle for my bad one. All right. This is a 5 Newton force pushing on the box. Start out with an easy one. What is the total force acting on the box? Oh, -6. That's not -6 in the answer. That's on a 10-point problem. I would take off 6 points for that answer. No, I just marked that wrong. I heard 5. I heard 2 people say 5. Others might have said it, and I just didn't hear it. If you watch the orientation videos, you know I don't have great hearing. The next Monday, I go for consultation on a hearing aid, so I might be able to hear you by the end of the month.
5 newtons.
Ah, okay, -3 now.
5 newtons of force.
Oh, no word. What do all vectors have?
Direction?
That's the part we're missing. How do you indicate the direction?
Lead with vectors.
So, somebody said something and I missed it.
The arrow.
So just draw out, so the total force, 5 newtons that way, just write it like that.
To the right.
One more time.
To the right.
To the right, oh, right out, to the right. 5 newtons to the right. Yeah, you could do that. That's so much to write. I don't feel like writing all those words out. Surely there's a faster way of doing it.
Is it the direction of the arrow?
This arrow right here,
Yeah.
no, that's pretty much standard, that it's gonna go point in that direction. That's not the way that they do it. However, one way of doing it, you could write out to the right, and that's gonna become tedious after a while, once we get into more complicated things. Another way we could do it is just go, well, you know what? I'm just gonna make to the right positive. And so I just write at the top, to the right's positive, and so now, when I write 5 newtons, it's a positive number, and I said positive was to the right. So you can get away with that. If it's a one-dimensional problem, you can get away with that. If it's not a one-dimensional problem, you can't get away with that. The other way that we can do it is we bring in the unit vector. What I'm gonna do is I'm gonna draw an arrow to the right, and apparently several of them. I'm gonna draw an arrow to the right, and I'm gonna put a hat over it. Because I have now defined I hat to be to the right, anytime I write I hat, it means to the right. So my answer is 5 newtons I hat. This is also an acceptable answer. But if you are going to use the shorter notations, you do have to define the directions. Because I hat is not always to the right. It's to the right because I said so right here for this problem. Suppose instead I said I hat was this way. What would be the answer? How do you indicate the other way?
Would you put it in front of the 5?
No. Though that would be an interesting technique, that's not what is done. If you're on a number line,
Negative?
there we go. So if I say to the left is negative, then this would be negative 5 newtons I hat. Now, even though the negative is indicating direction, it's negative I hat, you put the negative in front. If you put the negative in front of the I hat, so after the 5 newtons and put the negative in front of that, you gotta be careful, because if you write 5 newtons negative I hat, if you write it like that, it looks like you wrote a subtraction problem. That's 5 newtons minus I hat. If you want to do it that way, you have to put parentheses around that. So, but traditionally, the negative goes in front. Even though it's part of the direction. Those two indicate the direction.
So I hat means right, negative I hat means left.
I hat means whichever direction I said it was, or whichever you say it is, negative is the other way. So what you just said works for here. Over here it's the opposite, because here I said to the left is negative, goes I hat. So negative would be right.
So then who determines that?
The person writing down the answer.
So it's not based on the question, it's based on the answer.
Yeah, it's based upon the person who works it out. Now, as a class, I will typically, sometimes I'll just throw it up and say, do you want to make, which way do you want to make a positive I hat? And somebody just works out something and we'll go with that.
So we're answering a question, and we're dictating that I hat means whichever direction. How are you gonna infer that?
I'm going to see which direction you said was I hat, because you need to write down which, so by writing this down at the top, I'm now defining I hat.
Oh, okay.
And so now I can write this.
Okay.
So what I would do is I would look to see where you defined it. Other questions? All right. Let's make it look more complicated. I have a box. I apply 5 newtons on it that way, and I apply 3 newtons on it that way. What is the total force acting on the box? I saw one person mouth who's part of the answer.
Would it be 8 newtons of force with you to add? I don't know, never mind.
More confident. Don't ask, just tell me.
Is it 8 newtons of force? Do you
Oh,
have?
you asked again.
I guess that's what it is.
I think that's what it is.
It is, the magnitude is 8 newtons, but we still need to have that pesky direction. They are going in the same direction, so it would be 8 newtons. Do we want to write out all those words?
I have,
So you defining I hat how?
the arrow pointing to the right.
Okay,
And I had in front of it.
so we're gonna define I hat meaning to the right, and so it is 8 newtons I hat. Done. Now, let's say that you're in a panic, you know, on quizzes and tests, you get to a certain point where suddenly your mind blanks. Is there another approach? Yeah, there is. Let's take another approach at this. I have two forces on there that, excuse me. I have two forces that I need to add together. One of the forces is 5 newtons I hat plus 3 newtons I hat. And my eyes are looking like J's there. Let's see if I can do that a little bit better. And then you combine like terms. I got a Newton I hat here, Newton I hat here. Well, I got 5 there and 3 here, so I gotta have 8 total. I got 8 newtons I hat. But your mind's still blanking. You're not thinking in algebra terms. You're thinking, well, if I only I could draw a picture. Well, let's draw a picture then. I have 2 vectors there that I'm adding together. And when you're adding vectors, graphically, you have what is known as the head to tail method. Hewitt in the textbook will talk about the parallelogram method. I'm not as big a fan of that, because if you're adding more than 2 vectors, it becomes really cluttered. However, head to tail, or it probably should be tail to head. What you do is you start out with one of the vectors. It doesn't matter which one, you just draw one of the vectors. Let's say I'm just going to start with a 3 newton. So that length right there represents 3 newtons. So this is my starting point. I ended right here. So now I'm here. I now draw my second vector, the 5 newtons. Now, if I'm doing this really precisely, I'll make sure that that's 3, that this is going to be